Welcome to section 11.7. We are adding and subtracting radicals in this section, and that is pretty radical, dude. I know you guys are now probably looking at me or thinking about me and thinking, Miss Beardsley, you're a major dork. Oh well, so adding and subtracting radicals. It's honestly very similar to adding and subtracting like and unlike terms. So, like terms for radicals include things like this: 2 square root 5 and 4 square root 5. They are like terms, or they are like radicals, because their radicand is the same. That means we have 2 of something. Essentially, we have 2 of something, and we have 4 of that same something, so we would have a total of 6 of that something. As well, another sort of like radical is 6 square root x and negative 2 square root x. So as we can see, it does not make a difference if we have positive or negative coefficients in front of our x. And our last radicals that we could see as like terms are something like 3 square root 4t and square root 4t. So, in other words, there's that invisible 1 in front of that square root 4t, but we can add these because, once again, their radicands are the same. Unlike radicals, as you can tell from my statement, are situations where we do not have a radicand that is the same. So the stuff underneath that square root symbol is not the same. So if I have 2 and the square root of 15, those are unlike, because they have, well, this 2 doesn't even have a square root, and this 15 cannot be simplified to anything but the square root of 15, so the radicands are different. Another situation could be 6 square root x and the square root of 6x. These are unlike, so we cannot add them because the radicand for here is x. The radicand for this one is 6x. 6x is different than x, and so therefore those are unlike terms. They cannot be added. And then the last one, the one that kind of gets people tripped up, is we have 3 square root 2 and maybe 2 square root 3. And in this case, yet again, we have a situation where the radicand is different. Even though these look so similar, they're totally different. They cannot be added. So, let's actually add and subtract some radicals. Here we go. We have 3 square root 7 plus 8 square root 7. So if we look at this, we have 3 of this thing and 8 of this thing. So we have total 11. 3 plus 8 equals 11. And we still have that same square root. So that square root just follows us into our answer. So our answer is 11 square root 7. Let's try the next one. We have 9 square root y minus the square root of y. So that 9 square root y minus the square root of y, we're not going to just say the answer is 9. It's not. Instead, we actually have an invisible 1 right in front of that square root of y. So our answer would be 9 minus 1, which is 8. And we still have the square root of y. So 8 square root y is our final answer. Here is our next problem. We have 12 square root 2 minus 4 square root 11, and I look at this and I see different radicands. They are unlike, so my answer to this problem is 12 square root 2 minus 4 square root 11. Final answer, completely simplified. That's as far as we can go. Last one is one that's a little bit more in depth. We have negative 8 square root 3d plus 6 square root 2d plus 10 square root 3d. Just like we have done in the past when we have maybe 6x plus 6x squared plus maybe 4x, we need to find those like terms. Here's one like term, here's another like term. We can do that same thing with this problem. We have negative 8 square root 3d, and we have 10 square root 3d. They have the same radicand, so they can be added. Negative 8 plus a positive 10 is 2, and we still have our square root 3d attached to it, and we're just going to drag this baby down, so we have 6 square root 2d. Final answer. Now, Unfortunately, life can't always be this simple, and unfortunately we end up with situations where we have to simplify before we can actually solve anything. So we have situations like this. We have, in this case, 12, square root of 12, and the square root of 27. Square root of 12, I know there is a factor inside that is inside of 12 that is a squared number, and that factor is 4. If I multiply 4 by 3, I have a squared number and an unsquared number. I can also do that with 27. I have 9 and 3. So I'm using that product property that we used the other day to solve this. I have 4 square root of 4 times the square root of 3 for the 12 plus the square root of 9 times the square root of 3 for 27. Square root of 4 becomes a 2. Square root of 9 becomes a 3. So we have 2 square root 3 plus 3 square root 3. That comes out of these two situations. So our final answer in all of this is 5 square root 3. Kind of interesting. It's a little bit simpler to look at. Now let's look at the next one. We have 3 square root 8 plus 45. Let's actually figure out if we can simplify this. If I look at 8, I know I can break that down into 4 times 2. And if I look at 45, a squared number that comes out of 45 is a 9, and that is 9 times 5. So I could rewrite these two expressions as 3 square root 4 times 2 plus square root of 9 times 5. So let's do that math here. We have 4, the square root of 4 can become 2. Square root of 9 becomes 3. So 2 times 3 is 6. So I have 6 square root 2 plus 3 square root 5. And if I notice, 2 and 5, those are unlike. So our final answer is 6 square root 2 plus 3 square root 5. Let's try another problem. We're going to just try one more after this, and then you'll be set and ready to go for your homework. We have 5 square root 28x minus 8 square root 7x. So I can tell that I have a square root 7x, and that is already in simplest form. However, my 28x, that is not in simplest form. We can actually take out a squared number from the 28. We have 4 times 7, and I actually really see a nice thing with that 7. That 7's not going to come out of that square root sign. The 4 will. And if I notice, I'm probably going to end up with the same radicand. That means we'll be able to do some math. So we can finish this problem up by saying it is 5 square root of 4 times 7 times x minus 8 square root 7x. The 4 is going to pop out and become a 2, so we have now 5 times 2, which is 10 square root 7x minus 8 square root 7x. Final answer will include these two things subtracted, so 10 minus 8 is 2, and square root of 7x. Final answer. One last problem, and it's going to be similar to the other one where we have 3 terms. We have the square root of 125b plus 3 square root 20b minus 45b. So let's find those squared numbers that can come out of there. If I look at 125, I know I can put a quarter in there, so 25 times 5 gets me 125. If I look at 20, we can say 4 times 5 gets me 20. If I look at 45, 9 times 5 gets me 45. And if you noticed, I always wrote my squared number first, just so that way I was aware that is what I was searching for in the first place when I broke them up. So we have 125, that becomes 25 times 5, and we still have our b, plus 3 times, or square root 4 times 5 times b, minus 9 times 5 times b. After doing all that, let's actually deal with the square roots. 25 becomes 5, 4 becomes 2, 9 becomes 3. So my final answer, no, my almost final answer, my penultimate final answer is 5 square root 5b plus 2 times 3, which equals 6 square root 5b minus 3 square root 5b. I can now do a little bit of math. 5 plus 6 minus 3. 5 plus 6 is 11, minus 3 is equal to 8. So my final answer will be 8 square root 5b. Done. I hope this helps. I hope this becomes a helpful movie for you. So please enjoy the homework, and I will see you tomorrow. Thanks so much. Bye.